Today, I will teach antenna for you because you people are not listening to my digital. Is that okay? What? No response? At least as a joke, you should laugh, you know? You people stop reacting or what? Hmm?
Ma'am, not audible properly.
Oh, I'm not audible. Oh, actually, I'm walking. I'm walking here and there. Basically, from now it's I find I think no. I think it should be fine. Am I audible now?
Yes, ma'am, audible.
Yes, ma'am. Yes, ma'am.
My question is, who is the mastermind behind this to put me out of the meeting? Desperately from 3 o'clock I was trying. Who is that? Who is that? Actually, network issues, I think, right?
Yes, ma'am, network issues.
I think network issue. Other classes are not having any network issue? No. So that's why I will teach you today, Agna, for you. You can understand this?
Ma'am, can you repeat?
You people can understand this? What is visible here?
Ma'am, not visible.
It's not visible. Excellent. My video is also off, huh? Nothing is visible. Board is not visible?
No, ma'am.
We have not
Oh,
shared your
God.
screen.
Not screen, ma, my board. Whiteboard. Very. Now, board is visible.
No, ma'am, not
No,
visible.
ma'am.
No, ma'am.
Only
No,
voice
ma'am.
is audible.
Only voice is audible. Okay. I think. That's what even I was wondering. Why my camera is not on? Now, it's funny. How come my voice is the same thing is taking the same camera will take, and my video is not on. So what I'm supposed to do? You can't see whiteboard.
No, ma'am.
No, ma'am.
Okay, ma, just a second. These bloody fellows. What's happening? Now what's my fate?
The team of
My audio is okay. And video?
No, ma'am.
No, ma'am.
No, ma'am, no video.
No, ma'am. Yes, ma'am. Now it is visible.
Audio and visibility is Asna. I mean, board is visible.
Yes,
Yes,
ma'am.
ma'am. Yes, ma'am.
Very good. Now learn that only today. So because you people are not kept me on time digital, so my 15 minutes gone. Right? You learn this better. Antenna you will do. How many of you like EMF theory? Okay. In your maths, how many of you like the Green's theorem? Otherwise, the Lagrange series, the Maclaurin series, how many of you like? People like or not? Dislike?
No, ma'am.
It is for first one more or second one more? Dislike. What? No answer. You people stop talking or what?
No, ma'am. We are.
Like, ma'am.
Yeah?
No, ma'am.
You like or you like? Dislike?
It's like half of the thing we have not read.
Oh. But you know, EC department and all, they are giving a lot of assignments, it seems, right? So I think for you also we will start. We should start.
No, no, no.
No? No. Oh.
No, ma'am. No, ma'am. That's okay.
No need. No need. You chill, you chill, you chill. You people enjoy like that only. Okay. So anyway, because next 4:15 class is not there any fair for you, I'll extend. Not there, no? I know. Shweta has told.
Ma'am,
we
I
have.
didn't say that.
Shweta, immediate reaction. Okay, quickly. Right. So last class we were discussing decoders, I think. Yes? Yes or no? So
Yes.
in the
Yes, ma'am. Yes, ma'am.
decoders, okay, in the decoders, basically applications we are going for very high level, like what we say 7-segment display. But have you ever seen that how the circuital connections will be? Have anyone have tried for that? And by the way, I have given some one question, and so many people have done. That's very good, but I have not gone through, to be frank. Weekend, so that's what. Now today I will see definitely. So decoder is there. Then afterwards, their connections to the 7-segment displays. Right? So the each decoder, whatever the size is, whatever the size might be, in order to exhibit a full word, we may use different decoders. Is that correct? So in the total circuit will be the combinational circuit. Please try to remember. We are
Hello, ma'am.
Hello.
Hello.
Ma'am, you're stuck.
if and when I am out.
Ma'am, now you're audible.
Oh, for the past 5 minutes, whatever I said, 7-segment display, or you didn't listen?
No, ma'am. Ma'am, screen was
Huh?
screen was frozen.
It was frozen. What is this frozen here? Why this nonsense is coming? Am I audible?
Yes, ma'am. Audible.
Yes, ma'am.
Board visibility is there?
Yes, ma'am.
Okay, I doubt, no, seriously, today we can do anything or not. Okay, so now let us go to this combinational circuit decoder which you have studied is used for basically application. I have mentioned it as a 7-segment display. Is that correct? Right. So now, if such type of displays are required, like I want a series of 7-segment display, a word to be displayed, like NIT RKL. Am I audible?
Yes, ma'am.
Yes,
Okay.
ma'am.
So now, if at all you want some NITRKL, that means depending upon each alphabet, that means this is one 7-segment display. So you need a 3x8 decoder. Next, another one. So like that, you can make a bunch of decoders together and then use that for the application. Right? Internal circuit is a bit tough, but still you can do that. Right? So now, next thing is, what exactly is the internal circuit of a decoder? If you remember, what is there inside the decoder? Yeah, you had AND gates, no? You will have X and Y. Then afterwards, 2 inputs and 4 outputs. What you will have? Decoders. I think I have done this, I guess. Is this correct? This is what you have done. No? So your combination will be what? D naught means what? X dash, Y dash only. No? D1 means what? X,
X, Y dash,
Y bar.
X, Y.
X bar Y, then
Y,
X,
Y
Y
dash.
bar, then X, Y. This is what happening. So I don't think I require to explain this. Now, next comes the encoder. Right, the next circuit will be encoder. What is encoder? It's just reverse of this. Okay, that means you will have 2 for N inputs and N outputs. 2 for N inputs and N outputs. So what do you mean by that? Encoder does the work of just opposite of that of a decoder. Is that correct? That is what the table shows. This is encoder. Right. So how the truth table will be? Normally, you will have the encoded outputs like you can say Y0, Y1 up to N. Right. You will have some bits like how many bits, whatever. Okay, Y is already used. So up to Z. Right. So if at all you take 8x3 encoder, how it looks? You will have 8 combinations this side, this side. Then afterwards you have to just fill it up. Is that correct or not? So what will be the encoder truth table will be for 8? I am taking as Y0, Y1, Y2, Y3. So horrible. Okay, I'll just take. Okay, then I will use X1, X2. Okay, so if at all I'll use now what does it shows? I'm just attaching this input to the this is output, these are outputs and these are the inputs. That means for every one input we have a coded form coming outside as the outputs. Is that correct or not? It's just a 4x2 encoder, the truth table. So now can you tell me what will be the internal structure of this? What can be the internal structure of this? Yes. Anyone? See, this is the truth table. I am telling this is a combinational circuit which is in a and it is in the box. I want what can be inside the box.
Ma'am, inverter and NAND gates.
No, that's what I was asking. So anyone 2x4, 4x2 encoder in internal structure, can anybody show?
Ma'am, OR gates, AND gates, and
That's
inverter.
not. Yeah, that's what. See, when you write this x1, now question comes. Specifically, I will have 4 by 2 only. Okay, first year people are doing what you guys are. 4 by 2 is there. This is y0, y1, y2, y3. This is x1, x2. Now, how I will open this? This is my truth table. What will be my x1? What will be my x1? I am using min terms. What is my x1? This and this, right?
2, 3.
Yeah. So,
2, 3.
is it 2, 3? These, no? 2, 3 what? X1 has to be expressed in y's. What is 2, 3? I didn't understand.
4, 8.
Don't tell anything. Just give the midterm
Ma'am,
combination.
is it y3 plus y2?
Yes. Y.
Ma'am, it is y3 plus y2.
Yes.
Yes,
Y3
ma'am.
plus y2 it should come. So if you can reduce that, it will be y3 plus. I was about to fill this one. Y3 plus y2. Is that correct? X1. And what about x2?
Ma'am, it is y3 plus y1, y2 bar.
Y3 plus.
y1 and y2 bar.
So x2 is coming this one plus this one. Okay. Y3 plus y1.
y2 bar.
Okay. Now x1 and x2, if you are checking out, you have a combination of OR gates as well as AND gates and inverter gates. Is that correct or not? The internal diagram is what? What is x1 leading to? What is x2 leading to? The input combination will be diverted here. What will be the decoder format? Decoder is what? We have n inputs and we have multiple outputs. All are connected in a AND array. Is that correct? If you remembered. So, same thing, just pull down. I will put as a decoder. Now you tell me, this is 2 by 4 decoder. Now what is y0? What is y1? What is y2? What is y3? This is with this, attached with this. What is that one? Y0 is what? Decoder, decoder, I'm talking about decoder. What is y0? Quickly. What will be y0? It will be x1, x2, no? This much only or something else? Alright. Yeah, please tell what will be the truth table of this? Hello? Am I there in the meeting or you are not there?
Yes, ma'am.
Yeah. Can you tell me what will be y0, y1, y2, y3? Give the truth table of this one. Very important. Because, yeah.
Ma'am, X1 bar, X2 bar.
X1 bar,
X1 bar,
X2 bar.
X2 bar.
That is what I'm telling you.
Yes, yes,
X1,
ma'am. Yeah, that.
X1 bar, X2 bar. Is that correct?
Yes,
What
ma'am.
about this? Y1 means?
X1 bar, X2.
x1 bar,
X1, X2 bar.
X1 bar, X2.
So
X1 bar,
Y1 is
X2.
this one. No? Then X1,
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 X2 bar.
x2 bar.
X2 bar.
X2 bar.
then
X1,
X1.
X2.
So this
Yes,
is
ma'am.
your decoder, this is your encoder. Now comment it. Comment what is happening. In a decoder what happens and encoder what happens. See, this is a encoder, today's topic. That is already you have understood that. Now tell me what encoder does. But the people say encoder and decoder, they're just opposite to each other. Are they opposite? What is the encoded job means? See, encoding comes like when we have a series of input, we are giving that in an encoded format in a specific outputs. Now if you see x1 and x2 for this simple example, what x1 is giving? It is a combination of y3 and y2. Right? And what x2 is giving? It is a combination of y3 plus y1, y2 bar. If you see the truth table, what is happening? x1 times x1 is only responding to y2. x1 is responding to y3. It's two combination only it is taking individually. x2 is responding for whom? It is responding for y1 and it is responding for this also. So is that an encoder? I mean, are you understanding this one? Encoder and decoder are reversed with each other. Is it obliging that rule? Hello? Is that obliging the rule of your reverse to each other? Hello?
Yes, ma'am.
There are some network issues, I think, ma'am. For colleges like that. Yeah. Till now you didn't listen?
Yes, ma'am.
You listen?
Yes,
Yes,
ma'am.
ma'am.
Yes,
Okay.
ma'am.
Now my question is, are we like encoder and decoder? How I'm going to put in a same slot? Are they reversed with each other? Or how we will tell? Explain them. Encoder means encoded format of the input. Decoder means we will decode the input. That is what the meaning. Okay, layman definition is that. Is it working out that rule? Is it really working out? You are there? Is this correct?
Ma'am, can you take the camera to the right? Little right.
Okay, little right. Fine?
Yes, ma'am. Fine.
Now, is this correct for a decoder?
Yes, ma'am.
For a decoder, this is correct, and for the encoder, this is correct because your this is what it your truth table tells. Because truth tables are like that.
Yes, ma'am.
Correct. So now, can we say encoder and decoder are opposite to each other? Is oh God, these people will kill me. No. नहीं Okay, this is the classroom room view. Can you just call me after some time? I'm sorry. Hello.
Yes,
Yes, ma'am.
Ma'am, but
Yes. Four things here. You are.
there are
We can't. I am not able to listen you. That's the problem.
ma'am, in decoder there is no don't care conditions, but in encoder there are don't care conditions.
Okay. You are telling don't care conditions are there in that. Okay. So how you are looking into the don't care there?
No, ma'am, means I am saying a difference only.
In the differences. Okay. So I think Hiranmay has pointed out.
Yes, ma'am.
Okay. So anybody else wants to throw some light on that? See, today class anyway useless class it became. So question comes like if people at least can discuss till the network will be okay. Because these networks are like that only. Today I think from morning it is having, but morning my PG class was right fine only. See, if at all you can see your decoders in simple. You people are there or not?
Yes, ma'am. There.
Yes, ma'am.
Yes,
So
ma'am.
I can put it very crisp that it generates all the minterms of the input combinations. Is it clear? Decoder means that I can tell in crisp because it generated all the minterms of the input combination. Is decoder means?
Yes, ma'am.
Okay, so that means if it generates all the minterms of the input combinations, so the output combination means outputs whatever we have the combinations, we can utilize them according to our application. That means, for example, there are 4 outputs. I have 4 minterms already generated. I need not use everything. I can only use these 2 for one application. I can use the top and the bottom one for another application. Is that correct? So, a simple decoder can be defined as a minterm generator. Is that clear? Everyone agrees?
Yes, ma'am.
Now coming back to the encoder. Now who is encoder? Encoder means what? Now how I will define encoder? Encoder means what? It performs the inverse operation of a decoder. That's what the literature shows. But I am not able to see that in the truth table. Is that correct?
Yes, ma'am.
So how I will going to oblige that statement? Is it performing the inverse operation of a decoder? Okay.
No,
Now,
ma'am. Completely.
yes, ma'am. It is not performing, right? Hello. Is it performing?
Think no, ma'am.
No. It is not. So now let me do a small change here. Okay, this is fine. This is correct only. But I am going to do a small change here. I will introduce a variable. Okay. And I will try to change this also. Right? Okay. Then afterwards, this is okay. Now this P, I will not tell the row. Okay. Now the truth table, if at all, it's like this. Okay, this is correct. Encoder is correct. Okay, you keep this one. Another method I am trying to explain. It is like this. Okay, a truth table is provided like this. Are you able to understand? The input of the truth table is like this. Okay, now P, the column P, which is at the output. Are you people able to understand what is that P means?
Ma'am, priority.
Yes, P is priority. Okay, P is priority, but carefully understand what exactly the priority does.
It gives y0 the lowest priority and y3 the highest priority.
Yes, that is like that. Y0 is the lowest priority, Y3 is the highest priority. So what do you mean by what I fill the priority means?
Ma'am, means if y3 is 1, then we need not see we need not consider y2, y1, y0,
Yes.
y0.
Yes.
Yes, ma'am.
Okay.
And similarly for y2, ma'am.
You did not consider the other y1, y2. If at all you will consider y1, you did not consider. But what exactly these are telling us? What exactly these are telling us? So this is all one priority. See, y0 is there. This is one priority. So this one means only one. Y1 this, y2 this one, y3 this. But what about these factors? Right? And why this column has to be in use? Now, if you see here carefully, this is an encoder which is having some priority. P stands for priority or telling. But what priority we are trying to give? If at all this is active, okay, this is active. How it is linked with the other two? That means only check this one, don't check the other things. That's what it is telling. So here y0 represents only the combination of x1, x2. Don't check this. That is what you are trying to tell.
Yes, ma'am.
Right? And if at all y1 is there, don't check the others. Only this particular portion only you take this combination. y1. So y2. Then y3. So check this combination only. So in that case, if at all you understand, you will have just the meaning of a decoder only. I mean opposite to a decoder. Is that correct? So x1 means x1 combination and x2 combination. If you see, these are the outputs. So x1 has to give rise to the input side and y1 has to give rise to the input side. So how we are going to combine them? Am I in the meeting? I am out of the meeting. I think your next class also won't be there. There is no internet now.
Ma'am, you are there.
I am there in the meeting, but here I think in the internet is not. Okay, so now this particular topic, what I am trying to tell is, see, if at all the encoder performs the inverse operation of a inverse function of a decoder, how exactly we are able to understand? Like for example, this is a 4x2 decoder. Okay, I mean 4x2 encoder, right? So that means if the input y0 is 1, right, and the other inputs are all zeros, right? Then the output, what happens? Then the output is what? x1 and x2. And what the combination represents? It is 0, 0 combination. Is that correct?
Yes, ma'am.
So this is what it is. So if more than one input can be 1 at the same time, then the output will be defined according to the priority scheme. This is what a scheme is. See, for example, here I am trying to explain. Here this y0 is 1. So you need not worry about this. So this particular one represents x1, x2 as 0, 0. Right? Yes or no? And now here y1 represents what? x1. What is that? y1 represents the combination of x1 bar x2. That's all. And y2 represents, don't worry about others, just follow what it is telling here. Priority is given. The priority is measured only for the ones which are active. So this is x1, x2 bar. And y3 is x1, x2. Is that correct? According to this, I mean, okay, 0, 0, this is 0, 1, 1, 0, 1, 1. Okay, so now this is what a priority encoder is. I hope you will. Okay, ma, do one thing. No internet. Seriously, my voice only is echoing here. Okay, tomorrow
Ma'am,
class I'll take. Even?
ma'am, so in this one, even if we give multiple inputs, only the most significant one will be
Yes,
considered, right?
yes, yes. I wanted to tell that only dear. From the beginning, I'm shouting at that, Aman. This
Okay,
is
ma'am.
not right. Yeah. So here, what we are trying to see is like here, in this particular case, we are getting what? A version like x1 and x2 in terms of the input. Like I think Hiranmay has pointed out, we don't care something. But he kept in a different manner. Is that correct, Hiranmay?
Yes, ma'am.
Yeah, so that is what I'm trying to unfold. So here we will introduce, please look at the terms which are active and the rest of the things you forget. This is what I have told. Now, for example, I'll tell you another one. Simple. Forget it. I'll just give you two tables.
Hello, ma'am.
Yes, ma'am.
Ma'am,
Yes.
I have a doubt. Like the priority is fixed, or we can choose the priority, right?
Yes, you have to choose. That's what now the design means. You can choose any type of priority. That's what I'm changing now. Just see. Just see. I will just give you two tables. This is not an encoder. Please think. I have y1, y2, y3, y4, y5, y6, y7. Okay. Just I'm giving the truth table. Now please, and outputs also I will give. Okay, so now y0, y1, y2, y3, y4, y5, y6, y7. These are all inputs. How many inputs are there?
8.
8 inputs. Right? Now I will have outputs 4. Okay, now I'm just giving very simple thing A, B, C, and this is another one called P. I will write that separately. Okay, now this 8 inputs have to be connected to the outputs. Okay, think carefully. The 8 inputs have to be connected to the outputs. Right? Now, what I'm going to do is, I will follow a strategy. Please try to understand. So, I will just go like this. I'll fill up it.
Hello, ma'am. Hello, ma'am.
Yes, no?
Ma'am, for first row, ABC should be don't cares, and for the second row, ABC should be 0, 0.
It should be, or there will be a
Yes,
flaw.
ma'am.
I'm not telling
Yes,
it is an
ma'am.
encoder or anything. I'm just taking it. It is my design. Now I want a combinational circuit for this. See, if at all I will tell you the combination circuit, you will understand. That's not the point. Now I have an option like this. Now what will be the output? That is what the design should be. Okay. It is like this. Right? Okay, these are my inputs. Now what you are telling? Okay. I'm changing it. Okay. Okay. Now this is what. Now analyze this circuit and tell me. Analyze this truth table and tell me. Yes, anybody? You guys are there? Okay. Now, I want you to focus any term. Like for example, to analyze this. What is the meaning of this one? Y1 is 5. Y1, Y5. Please try to understand. Y5 is highlighted. Am I there in the meeting or not? You are there? Quickly.
Yes.
I'll give you some inputs. Okay. This rounded one. This is 1.
Yes.
Okay. So when if this is active, I am not worried about Y0 to Y4. Okay. Y0 to Y4. If this is active, I am not worried from this to this. If this is active, I am not worried about what does it mean. So what does it mean? So the active element will decide what output has to be there. Like basically, we are distinguishing all the signals which are 1 from zeros. This is what the concept. Don't you see that? Forget about encoder. Don't you see as an engineer, you just check out. We are exclusively distinguishing or we are keeping it separate. 1 separate and 0 separate. Don't you see the table is like that? Because you see, Wi-Fi is highlighted. It exactly is combination of 101. We are not worried what exactly the other things are happening. When this is active, it only represents 100. It is only indicating which are active. Don't you see that? Everyone.
Yes, ma'am.
Yeah, this is what actually an encoder is. Normally, the previous one, what they say that this is inverse of decoder. It is inverse of a decoder, but it has a different analysis to observe. It's not like simply inverse of decoder. Is that correct? The don't care terms over here are more prominent. Please try to understand. The don't care terms here, right? We are exclusively separating the terms which are highlighted, right? So now, if I say this input is given 1 0 0 0 0 all is given, we will get an output as ABC as only one particular encoded version, which is 0 0 0. That's all. We don't have any other option. That means we want, like for example, we have a code language. We will tell you encoded form of this string is only 0 0 0. Don't you see this string? This string and this string, these two are encoded differently. That you can see, right? This is encoded as 0 0 0, whereas this string is encoded as 0 0 1. You people are understanding that?
Yes, ma'am.
String, you see the total string. Input means what? These are all full string for me. So this string is given means it is encoding this way. And if at all this string is given, it is encoded separately. Now why I am giving this as don't care? Even if there is 0 0 0 0 0 here, doesn't matter. It will give this. And even if it is 1 1 1 1, doesn't matter. It will give only this. Are you understanding? No two strings will have the same encoded version. This is what I want to keep. And this is just an indication to tell that only one has given a priority. Actives are given priorities. Now I think you should be understanding at least a little bit. Correct? Hello?
Yes,
Yes,
ma'am.
ma'am.
Yes, ma'am.
Please try to
Ma'am.
understand.
Yes, ma'am.
Yeah. See,
Ma'am.
each yeah.
Ma'am, class has started at other place.
Other place they started now network issues. Hey, tomorrow minus 250 in class now. Okay. Okay, ma'am, please go. I'll again repeat it. But this one, note down, try to analyze and keep my words. Like, what is this one actually? Each string is there. Each string is encoded in a different one. No two strings will have the same output. Did you observe that? That much I wanted to tell. Okay?
Yes, ma'am.
Okay. Please observe that. Okay, then you can leave. No problem.